Welcome to this lesson on writing equations. After today's lesson, I will be able to use substitution to determine if a number is a solution to an equation, use variables to represent numbers, and understand that variables represent unknown numbers, and then also write equations from word problems. So honestly, so far we've done these two things right here. Whoops, I guess if you want to be able to see what I'm writing, I should write with not white. There we go. So we've already done those two standards right there, those expectations, and we're going over them again. But in this situation, now we're going to do that with equations instead of expressions. We're going to have an actual solution or one answer to our question. I would encourage you to make sure that you have a highlighter for your notes, so if you need to, pause and take a minute to grab one. All right, so first we have the word equation. An equation is a mathematical statement containing an equal sign that shows that two expressions have the same value. So often we like to say that, so s plus 4 equals 9. That is an equation. However, you also have to understand that these are also equations. It doesn't have to just be, an operation on one side and an answer on the other. You can have two different things. So like I can have 2 plus 2 is equal to 1 plus 3. That is now an equation. All right, next, solution. The solution is a value that makes an equation true or values that make an inequality true. We'll talk about inequalities later on down the road. Right now we're talking about an equation. So notice, I want you to see here that it says a value that makes an equation true, where here for inequalities it's values. When it comes to an equation, only one number can make that equation work. Or one number per variable can make that number work. Right, so like in this case, if you go through and you solve using the distributive property, you get 2x minus 2 plus 8 is equal to 4x minus 20. And if you work your way through the problem, you find out that x equals 13. So x equals 13 would be your solution, because that's the only number that you can put in for x that will make this statement true. All right, so going along with that thought, we're going to look at these different equations that we have here, and we're going to determine whether the value that we've been given is a solution to the equation or not. To do that, you're going to use substitution. You're going to substitute whatever the number is that they gave you in for whatever variable it represents. So in this case, x is equal to 6, so I see that x plus 9 is equal to 15 as my equation. So I go through and I check to see, is 6 plus 9 equaling 15? Is that true? Well, if I actually do the math, and actually if I'm not sure, go through and double check and count 9, 10, 11, 12, 13, 14, 15. I do in fact need 6 to get to 15. So yes, 6 is the solution. So I'm using substitution to check my answer. So that's the nice thing about equations, once we start working with them some more, is that you can actually put your number back into the equation and see if you were right. So in theory, you should never have an incorrect answer anymore. So here we have y divided by 4 equals 32 for y equals 8. So anywhere I see y, I have to substitute in 8. So instead of y divided by 4, I have 8 divided by 4 equaling 32. Well, I know that 8 divided by 4 is actually 2, and 2 does not equal 32. So 8 is not a solution. All right, and then here I have 8 times x equals 72 for x equals 9. So I'm going to substitute in the 9 for the x. 8 times 9 indeed is 72. So I have 72 equals 72. Therefore, 9 is a solution. Okay, now it's your turn. You're going to go ahead and you're going to try these 4 problems on your own. I gave you some space on the bottom of your notes to work it out. You need to work it out to show me that, or to prove whether or not your answer works. And when you come back, we'll check your answers. So in this case, the answer was yes, it's a solution. Here it is no. Here it's yes. Ouch. And here it is no. So double checking that. So we have 6 plus 5. So 5 plus 6 equals 11. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6. If I add all those up, it does give me 11. There's really no good way to show 11, is there? All right, here I have y minus 6 equals 24, where y equals 18. Well, I know 18 minus 6 actually gives me 12, and that is not equal to 24, so that is not a solution. Here I have x divided by 9 is 4, where 36 is equal to x, so 36 divided by 9 equals 4, and that is the case, so that is a solution. Here I have 15 times t is equal to 100, where t is equal to 6. Okay, I know that 6 times 5 is 30, and 1 times 6, or 10 times 6 is 60. So if I add those two things together, I get 90. So this is 90 equals 100, which is not correct, so that is not a solution. All right, next step. This is where you need that highlighter, and we've been working on this a little bit so far. So Mark scored 17 points for the home team in a basketball game. His teammates as a group scored P points. Write an equation to represent this situation. All right, so what we're going to do is we're going to highlight, write an equation to represent this situation. All right, then you have this nice little picture over here to the side that shows you the scoreboard. So it's important to note that he scored the points for the home team since we have the home and the guest. And it's important to note that he had 17 points. And now in this case, remember the variable represents what we don't know. So they gave us a variable here and they tell us that it represents points. But let's be very specific. P represents, and that's, I just put equals as represents, and I'm going to type this so it goes a little bit faster. You're welcome. The number of points the rest of the team scored. Okay, because that's what we're looking for. That's the answer that we're looking for. All right, that's what we don't know. So now in this case, a lot of times what students want to do is they just want to hurry up and get the answer and do subtraction. But that's not the case. Mark scored 17 points for the home team in a basketball game. His teammates as a group scored P points. So they're asking you to write an equation to represent this situation. This situation being that Mark scored 17. The team scored P. Okay, that's the situation. Mark scored and the team scored. We know that you put those points together, so it's addition. And when you put those points together, we know that it gets 46 points. Okay, so the equation in this case would be 17 plus P is equal to 46. Most of the time when you're writing an equation, typically you're looking for a piece of information, and that piece of information is going to be part of the problem. It's not going to be part of what we consider to be the answer. All right? You have to think of the context. In a basketball game, you're not subtracting points, you're adding them together. You're taking whatever Mark scored plus whatever his team scored to get your total score. That's the situation, so your equation has to represent that. All right, so now what you're going to do is I want you to go ahead and write an equation for each of the problems. Not only do I want you to write an equation, but I want you to tell me, what does your variable represent? All right, and when you come back, we'll check your answers. All right, so Marilyn has a fish tank that contains 38 fish. There are 9 goldfish and F other fish. So there's 38 fish, 9 of them are goldfish, and F other fish. So F represents the other fish. And in this case, again, you're not taking fish away. You're taking the 9 goldfish plus the F amount of other fish to get 38 total fish. Juanita has 102 beads to make N necklaces. Each necklace will have 17 beads. Okay, so she has 102 beads, and she's making N amount of necklaces. So N equals necklaces made. And now here, each necklace will have 17 beads. So that tells us that you're taking the necklaces and you're putting them onto different, or you're taking the beads and putting them onto different necklaces, which when we talk about splitting things into group, that means division. So we're taking those 102 beads, dividing them by the N number of necklaces, and we should get 17 beads per necklace. Craig is C years old. His 12-year-old sister Caitlin is 3 years younger than Craig. Okay, in this case, 12 is important. So we know that since she is younger, we're going to take her age away from Craig's. So we have C being Craig's age. And if we take Craig's age and subtract 3, that should give us his 12-year-old sister. Younger implies that we're going to subtract. Kim rented skates for H hours. The rental fee was $2 per hour, and she paid a total of $8. Okay, so H equals hours, skates were rented. And I know that it's $2 per hour. So the per in this case tells me that I'm going to multiply. Okay, so it's $2 per hour that you rent, and that gave her a total, which we know goes at the end, of $8. All right. So last but not least, what you're going to do is you are going to complete your guided practice problems. Please make sure to fill everything out. Okay, and again, wherever it asks you to create equations, make sure you tell what your variable represents. And as always, if you have any questions, please be sure to email me or write them down so we can go over them in class.